increasing and decreasing functions and the first derivative test. So in this section, we will talk about the derivative can be used to classify the relative extreme as either minimum or maximum, basically. Okay, so now look at this definition. Of a function f is increasing on an interval if for any two numbers x1 and x2 in the interval, if x1 is less than x2 and fx1 is less than fx2, then it is increasing, which means the decreasing case, if x1 is less than x2 but the outcome fx1 is bigger than fx2, there will be decreasing case here. Okay, then whenever we see this kind of a definition, it is not usually clear. So I also draw some picture and then we talk about that. Okay, so just plain, and then make a little bit larger curve here, something like that. Okay, now I'm gonna just set up two x value. So this is x1 and this is x2. As you see, x2 location is on the right side compared to x1. Now we can say that definitely x1 is less than x2. And now you know, so when we look at this line from here to here, this is increasing. How do you know? So it's going up here, so it's increasing. And now this is the fx1, this is fx2. So fx1 definitely less than fx2. Now we say that in this case already increasing. Make sense? Okay, now decreasing case. So on this graph here, so maybe this part, so I'm gonna set up maybe here, and then here x2. So x2 is located from the on the right side compared to x1. So we also know that x1 is less than x2. And now this is the fx1, this is fx2. Compared to 2y value, fx1 is bigger than fx2, right? And then this is decreasing. How do you know? So line here, it is decreasing. So this case we can say decreasing basically. Okay. Then how can we define that increasing area and decreasing area using the first derivative? So the definition is here. So theorem, test for increasing and decreasing functions. Let f be a function that is continuous on the closed interval a and b and differentiable on the open interval a and b. Then number 1, f prime x is bigger than 0. Okay, then you better know what this means. F prime x, all this part, this one indicate tangent line slope, right? Okay, tangent line slope. So if this tangent line slope, if tangent line slope is positive, then you know that it means the line we can expect this way, right? That's the reason it is increasing. That's what this means. So increasing here. Now f prime x is less than 0. What does that mean? It's negative slope, right? Which means in this case we can guess the line looks like this. So it's decreasing here. Okay. Now, what if f prime x equal to 0? Then this is turning point, so must be horizontal slope here. Okay. This is what that means basically. Okay, then let's look at example and then analyze it. So intervals on which f is increasing or decreasing. So find the open interval on which fx equal to x cubed minus 3 over 2x squared is increasing or decreasing. Okay. So you know that whenever we have any random graph, something like this, okay, then based on this turning point, so I can define turning points here and here. Then how do I know? Because it is increasing to decreasing or decreasing to increasing. That's how I can find. Or at this point, we can make tangent line slope become 0 basically, right? So that will be our turning point here. It means after finding the critical value first, and then we can maybe test other x value, maybe belongs to the open interval, then we can analyze which interval is increasing and which interval is decreasing. Okay? So, first step is always finding the critical value. Then how to find the critical value? Yes, finding the derivative and make it equal to 0. Then you will find x value. Those have the tangent line become 0 and tangent line slope become 0. So I'm gonna find out f prime x first. So what I wanna do, I'm gonna write this again on the bottom part. So fx equal to x cubed minus 3 over 2 x squared. Now let's find out f prime x, and this become 3x squared minus 3 over 2 times 2x. So cancel this out. Therefore f prime x equal to 3x squared minus 3x. Okay. Now next step, we make that equal to 0. Okay. So now we have equations. So 3x squared minus 3x equal to 0. As you see, we have a common factor, which is 3x. So 3x times x minus 3 equal to 0. Okay. So we did quadratic equation a lot from the college algebra and then intermediate algebra. So just set up 3x equal to 0 and x minus 3 equal to 0. Then you will get 2x value, x equal to 0 and x equal to 3. Okay, those are our critical value. Are you with me? Good. Okay, then what I want to do, I'm gonna make number line here. Okay, set up 0 and then 3 here. Then we can find 3 open interval. So from negative infinity to 0. Okay, so this become negative infinity to 0 will be this area, and then another one 0 to 3 and 3 to infinity on the right side area. Okay, then why we are using open interval? Because when x equals 0 and 3, we have tangent line slope become 0. So we must omit those two numbers. That's why we are making open interval. Okay, now we make testing value here. So just find out any random x value belongs to this interval. It is up to you, but easy one is always better. Okay, easy one is always better. Okay, so what I want to choose, I'm gonna choose maybe negative 1. Here maybe 1. Why not? This become 4. So those are my testing value. Good? Okay. So now we want to find out which interval tangent line slope become positive, negative, or 0. 0 actually found 2x already. Okay, therefore you are plugging these x values into the f prime x, not just the original fx. The reason is f prime x means you are finding tangent line slope. That's why you have to do so. Okay, so I'm gonna plug all these value into f prime function basically. Okay, so let's do it. So I'm gonna do f prime negative 1, which means 3 times negative 1 square minus 3 times negative 1. Okay, then this become 3 times 1 plus 3, which is 6. 6 is positive number, which means in this area we can find the slope become positive. Okay, another word, increasing. Okay, now I'm gonna put 1, then f prime 1 equal to 3 times 1 square minus 3 times 1, so equal to, oops, I think I made one mistake. Let me find out. Oh, here, so I did the factoring wrong here, so this part, it become 3x and then x minus 1, sorry. So x equal 0 and x equal to 1. So this value becomes 1 actually. Okay, then I'm gonna choose not 1. Instead, I will do 1/2. Then this one, 4. I'm gonna keep it, that this interval value will be 1 again. Okay, so sorry about this. Okay, so f 1/2. Then this becomes 3 times 1/2 square minus 3 times 1/2. It means 3 times 1/4 minus 3/2 basically. So 3/4 minus 3/2 equal to 3/4 minus 6/4. So negative 3/4. So we got negative. Negative means minus. Minus means decreasing. Okay, so this interval I can say decreasing. Now f4, then 3 times 4 square minus 3 times 4, then 3 times 16 minus 12. So this become 48 minus 12 equal to 36, which is positive number. Okay, so again, this is a positive here, which means increasing. Okay, so therefore I can finalize the answer. So here, so increasing area, I can say negative infinity to 0 and 1 to infinity, and decreasing we can do 0 to 1, and then 0 at x equal to 0 and 1. That's the answer for this problem.